Today, we're going to discuss a very important topic. This will come up for the rest of the class, and you will be expected to use these numbers as we continue through. This is complex numbers. So, up until now, whenever you've taken the square root and you've gotten the square root of a negative, you've been told, well, the answer does not exist. Well, in some ways that's true, and in some ways it's not. The answer doesn't exist in the real numbers. But if we create a new category of numbers called complex numbers or imaginary numbers, then we do have answers that come with this. They are not physical answers, they are imaginary, so we can't use them in like word problems, but they are answers to solutions. So, what is an imaginary number? An imaginary number is what happens when you take the square root of a negative. So, we have defined when you take the square root of a negative, that becomes the imaginary unit I. So, let's look at our first example here. If we want to take the square root of negative 25, this now does exist in the imaginary numbers. So what is the square root of 25? That is 5. And then the square root of the negative becomes the I. So the square root of negative 25 is 5i. If we look at the square root of negative 20, well, the square root of 20 simplifies to 4 square root of 5, and then the square root of that negative becomes the I. Now, a quick little notation thing. You never, ever, ever, ever want the I to go under the square root. Generally speaking, I comes last after the number. The only exception is if you have terrible handwriting, you are allowed to put the I before a square root in the imaginary thing. Either one of these is accepted in both my open math and in Mrs. Hoffman's grading. But just remember, normally the I comes after the number and it never goes under the square root. That gets banana pants. If we look at something like this, where would you have seen something like this or calculated something like this in algebra 2? This could have been something that came out of the quadratic formula. And if we simplify this a little bit, we get negative 3 plus or minus um, the square root of negative 28 over 4. And when we did this, we would say, oh, well, there's no solution. Well, now there is a solution. And sort of the baby step start of this is, well, what's the square root of negative 28? Well, that's going to be um, 2 square root of 7. And then the square root of the negative becomes an I, and that's all over 4. Now, we'll keep going in a minute on this, but for now, that is an acceptable answer. Take a moment and try to do this next one. Please remember when we see something like this guy over here, 2 square root of 5, that's a 2 times the square root of 5. So when we're looking at this, that's 5 times the square root of negative 8. So thinking it through, the square root of negative of 8 becomes 2 square root of 2. And since the original 2 are multiplied, the simplified 2 will be multiplied. And the square root of the negative becomes the I, so we get 10 square root of 2i for our imaginary number that comes out of this answer. So this is how we start in the world of complex numbers with imaginary numbers. The square root of the negative becomes the I.